Welcome back. So now we're going to start looking at the addition method. And part of the reason we're doing that is because now I don't have any linear equations. Everything has squareds everywhere. Now, sometimes you'll only get squareds on one and the other variable is still linear. But here, now we're going to start seeing the squareds everywhere. So substitution here, if I tried to get any of the variables by itself, I would have to square root. And when that's the case, like I could substitute it in and the square root goes away, but it just starts getting really hairy. So since the x squareds are both x squareds or the y squareds are both y squareds, they're the same variable with the same power. They're like terms, like the top and bottom. Those two guys or those two guys, if I added, they would combine as like terms. So we're going to set this up so when I add the two equations together, equal things to equal things, I'm going to see a cancellation. Now, the nice thing here is since I have both positive x squareds, I just need to change the sign on one of them. And since the bottom one has a whole bunch of ugly negatives, we'll go with that. So now that's going to become a negative x squared, a positive 2y squared, and a positive 31. And then we just copy the top one right on top. X squared plus y squared equals 17. So we have a circle and a wonky circle. The wonky circle being called an ellipse. That's the fancy name, but looks like a Bert nose or an Ernie nose, like this way or this way. All right, so we add x squared minus x squared, cancels. Y squared plus 2y squareds. A square y plus 2 more square y's is 3 square y's. Equals 31 plus 17, that is 8 and a 4, so 48. And now this looks like a much more normal equation. Divide that 3 out of the way. Y squared equals 16. A number that square roots nicely. What a shock. Now, the next step, we are choosing to square root both sides. So we need to have the plus or minus. Different from the problem on the other video where it gave us the square root as the starting problem, like what you saw on the screen. This one, we're doing it as part of the process. This is one of the reasons why I use different colors, because now it's a different step. And because we're putting it in, we get the plus or minus. So y here could be plus or minus 4. And we are going to have to take the plus or minus 4. We're going to have to plug in positive 4 and negative 4. And then figure out the x values that go with it. Okay, so looking at the equations, I like the first one a little better. So we're going to start with y equals 4. And in the first equation, that gives us x squared plus 4 squared equals 17. I'm going to minus the 4, or square it first, so it's 16. And we minus the 16 over. We get x squared is equal to a 1. Lovely, another square rootable number. And then square root to both sides. We're putting it in so it gets a plus or minus. So x is plus or minus 1. So for one number, y equals 4, I got 2 x values. So that means I have 2 points just from that one y value. So let me write those ordered pairs down. So that is x is 1, y is 4. X is negative 1, y is 4. Now, when this happens, what you're going to see is the numbers like show up a lot. You're just going to have the positive or the negative version of the number. So check it out. I'm going to sneak in here and magically substitute in negative 4. That's a minus now. There's a minus in there, but it squares, and now we're back to the exact same work. I'm not writing it twice. So with negative 4, when y is negative 4, we also get plus or minus 1. So I got all the variations of plus or minus 1 for x with all the variations of plus or minus 4 for y. The order you write this list in does not matter for Alex, but you do have to write all 4 points. Make sure you put commas between the ordered pairs as well. That can look really confusing, so I highly recommend press the ordered pair button that drops the parentheses with the box and the comma for you. Move over, put a comma, put another ordered pair, move over, put the comma, put another ordered pair, another comma, another ordered pair. Get that set first as your syntax, then go through and type the numbers in, because you can just click on one tab and it'll work. But just be on the lookout for that. It's really frustrating to miss a problem because you put a comma in the wrong spot. Alex is pretty good about catching it though. Much better than other systems that we shall not name. Pearson. Okay. So now we're going to do it again. I have a circle and another wonky, this would be an Ernie nose, ellipse. So we are going to solve for them, see where they intersect. Now, since the first one, my coefficients on the squared terms are ones, I'm going to work this out so that the x's cancel since 4 is smaller than 9. And that is the only reason I choose that. I could just as easily multiply this by -9, but I'm going to go with -4, so I get -4x squared minus 4y squared equals -64. And you may be thinking, I don't know this. This is starting to look weird. Nah, just go with it. Starting to look weirder, Liz. It's okay. So the x's cancel. The y's, we're going to have 5 of them, 5y squared. And then over here, 64 is negative. 36 is positive. So 36 minus 64 is going to give us a -28. So I could divide by 5, sure, but what's the step after that? You'd square root. So I'll here divide by 5. And it's going to be 5.6. So we have y squared equals an ugly -5.6. And if I try to square root that, I'd get imaginary. No. And that's all I had. I didn't have another equation. I don't have another y value to check like we did before. We threw out one number before, but we had another one to fall back on. Here, I didn't have anything to fall back on. So that means these guys don't intersect. So there are no solutions to this system. So when you get something that would give you an imaginary, or you could also get an inconsistent system, that's the fancy name for this. And that happens when you get a false statement. Like in the past, we saw it would be like 0 equals 3. No, it doesn't. So it was false. So that's what this one is reckoning back to. It's when we had parallel lines. So no solutions. And if you actually take a look at the graph, what we have here is now I know 16 or 4 in this case is the radius is not that large, but that ellipse is still smaller. So I have a circle, and then inside the circle is this little Ernie nose that never is big enough to touch any of the circle. Now you can solve these for y and put them on a graphing calculator, but on these you're going to get a square root as part of the answer. So you have to type in y1 is the positive square root, and then you have to go down to y2 and type the negative square root. And what you're going to see is it splits the graphs into the top and the bottom. So that way it is 2 functions. The top on its own is a function. The bottom on its own is a function. The 2 considered as one graph is not a function because it fails the vertical line test. Yes, this is also quasi-acting as a review for your final. Well, for your college algebra final. All right, I'm going to have one more video where I do a word problem. Yeah.